Now that we know how to find the cross product, the next question is, what is it? Well, the cross product of two vectors, u and v, will always be orthogonal to both u and v. So it is a vector that is orthogonal to u and v. This tells me that I have u dotted with u cross v will be equal to 0, and v dot u cross v is also equal to 0. The cross product is by definition the orthogonal vector. The length of the vector depends on a few things. It depends on the lengths of u and v and the angle between them. In general, the magnitude of the vector u cross v is equal to the magnitude of u times the magnitude of v times sine of theta, where theta is the angle between them. So we have that the direction of the cross product is determined by the fact that it needs to be orthogonal to u and v, and the length or the magnitude is determined by the length of u, the length of v, and the angle between them. We can use these ideas to find the general area of a parallelogram in 3-space. Let's suppose I have a parallelogram defined by these vectors u and v. So we'll do an approximate filling out the rest of this to be our parallelogram. Here's our vector u, here's our vector v. The area of a parallelogram is determined by the length of the base, which is the length of u, times the height. And here's our height right here. If the angle between these two vectors is theta, well, I know that the length of this vector is the length of v. So I can see sine of theta is equal to the opposite side, the height that I need, over the hypotenuse, which is the length of v. Multiplying both sides by the length of v, I have the length of v times sine theta is equal to the height. So the area is the base times the height. So the length of u times the length of v times sine of theta, which is by definition the length or the magnitude of u cross v. So I can find the area of a parallelogram using the cross product. Let's consider a parallelogram with vertices given by these 4 points. And I want to find the area. In order to use this idea of the cross product, I essentially need one of the vertices to be at the origin. So I need to think about picking up this parallelogram and shifting it so that it's at the origin. And I want to shift this point so that it belongs to the origin. So I'm going to shift the entire parallelogram. In the x direction, I had to subtract 1. I had to move in the x direction by -1. So I'm going to need to do that for everything. I need to move in the x direction by -1. I needed to move in the y direction by 1 to get to the origin, so I'll do that across the board as well. Move in the y direction by 1. Finally, I had to move in the z direction by -2, so I'll once again do that across the board. Move in the z direction by -2. So all I've done is shifted my parallelogram. I haven't changed anything else about it. I can see that if I add these 2 points, I get the third, which tells me that the 2 points that I care about are these two. They're the two that are adjacent to my origin. They're the ones that are determined by these two vectors, whereas my fourth point, that -371, is the fourth point of the parallelogram. So I need to find the cross product of these. I'm going to ignore the first coordinates. That would give me 3, -1, 4, 2 times I, minus, ignore the second coordinates. That would be 2, -1, -5, 2 times j, plus ignore the third coordinates. I would have 2, 3, -5, 4 times k. This would be 6 minus -4, I minus 4 minus 5j plus 8 minus -15k. If we simplify this, we get 10i plus j plus 23k. Finally, we need to find the length of this cross product to get the area. The length is determined by the square root of 10 squared plus 1 squared plus 23 squared, which if you simplify gives us an area of the square root of 630 total units squared. So we have an area of the square root of 630. The cross product can also help us determine the volume of a parallelepiped. For a parallelepiped, we need to determine it by 3 vectors, u, v, and w. To find the volume of a parallelepiped, we need to cross 2 of them, so I'll do u cross v. And then we're going to dot with the third vector. And since volume is always positive, we need an absolute value here. So let's suppose I have this parallelepiped determined by -5, 0, 5, 1, 1, -4, and 0, 2, 6. I need to start by taking a cross product, and I'll start by taking a cross product of the first 2 vectors. Ignoring the first coordinates, I have 0, 5, 1, -4 times I, minus, ignoring the second coordinates, -5, 5, 1, -4 times j, plus, ignore the third coordinates, I have -5, 0, 1, 1, k. This is 0 minus 5i minus 20 minus 5j plus -5 minus 0k. If we simplify this, we get -5i minus 15j minus 5k. Now, I want to take the dot product of this with my third vector, my third point. So if I change my colors very quickly, I now need to take the dot product of these 2. Multiplying things in corresponding positions, I have 0 times -5 plus 2 times -15 plus 6 times -5. This would be 0 minus 30 minus 30, which is -60. So the volume of this parallelepiped would be 60.